My name is D. Kumar. I am a cloud solutions architect at Microsoft, focusing on data and AI. And today I'll be talking about Azure Data Lake Storage and our Synapse platform. So let's get started. All right, Azure Data Lake Storage. So before I go to Azure Data Lake Storage, just a quick refresher course on the types of storage we support on Azure. We have, hold on, I see this. Okay, so we have the traditional disk storage, which is in three flavors, the Ultra, Premium, and Standard, and pretty much a storage available for data on these virtual machines. Then we have this object storage, which supports the Azure Blob Storage and Azure Data Lake Storage. It is the massively scalable storage which we have available on Azure, secured storage and durable storage. So this is what I'll be talking about today. But other than that, we also have this file storage, which is when you use it typically when you're lifting and shifting applications from on-prem to the Azure platform, and you need a shared file storage. So this is the file storage we use. Other than that, we have the data transport storage, which comes as Azure Data Box or Data Disk, where primarily used when you are migrating large amounts of data to Azure and you do not want to hold on to your express route bandwidth or your internet bandwidth to do the job, but you want to do it much faster, more efficiently, more economically. That's when we would use Azure Data Box or the Data Disk. And the last of one is the hybrid storage, where we have the Stack Edge, the Stack Hub, the File Sync, where we let you provision Azure infrastructure as service and software SaaS services on your premises. But the storage you have there, you can keep it there. But if you want to get it refreshed with this having it centralized, then that's where we have capabilities to enable that transfer securely and between on-premise and cloud. So going to the next level, is there a way to minimize this tab? Okay, so today, talking about data, every business we know today is based on data. It could be data sitting on your laptop. It could be data sitting for your business use case. It could be data sitting in your databases. It could be data sitting anywhere. But the real thing is that data is the lifeblood of our modern work. Every organization lives on data. But then just ability to house the data is not of ultimate importance, but how can you derive insights and intelligence out of that data? Because if you are not able to build analytics, that data is just a cost center. You're spending money to just save that data, it's not using it as a resource to bring in business value to your business. And that's why, like most of our businesses, typically they are more and more engaged in building real-time dashboards, BI and visualization to show the state of business or getting insights into the data they have housed within their organization. And last but not the least, with the different kinds of data coming in, we need a good way to not only keep the data, but also see patterns and anomalies out of that data so we can take business actions real time. So behind this, in the last decade, a little over the decade, instead of using the traditional forms of storage, the storage mechanisms or having data lakes have become very common. The reason being, when you have to land the data to data lake, you get better insights. Why? Because absolutely there is no ETL in landing the data. The data, all you need is a place to land, and that just you can just store the data. It scales easily as your data grows, but definitely if it is on premise, you run into limits. But that's where when you talk about cloud or you talk about Azure, you can scale it easily as your data is coming from your source systems. And talking about low cost, definitely you have the cost to store the data and to make it available to you and to make that storage durable, and having cost structure and life cycle management policies on top of your data stored is the best way to manage costs. So your hard data can be on an expensive storage because people are frequently accessing it and you need a better response time. But you could set up a life cycle policy for that data to move to a cooler or a colder storage where you won't get those split-second response times, but still you are able to access the data. And if you do not need it, you can still store it. So that trade-off with how to manage cost and being readily able to build those, do that life cycle management is something which the folks are looking for. And that's great when you're doing analytics. And also you look for a platform where there is where you could do a broad set of analytics and bring different frameworks are able to work with that data. So with that background, Azure Data Lake Storage provides a massively scalable data lake storage with to enable high performance analytics. And it's scalable. It's a scalable storage, durable, high performance. You have performance tiers you can pick it up, build the lifecycle policies, secure and compliant, and having those identities and low-level granular securities on it, cost-effective. And the biggest thing is it's the foundation for world's learning, the foundation for most of our analytics platforms in the world today. All right, I'm trying to minimize this. Okay. All right. So, so what comes with data lake storage and the way the data is stored, you're able to apply POSIX controls to your data at the granularity level of the file. You can go at the folder level. You can go at the lowest granularity is at the file level. You could do that. Enables Active Directory authentication, multi-factor Active Directory multi-factor authentication, role-based access controls. We have around 96 certifications, also certifications for data sovereignty, where if you want to keep the data local, we do have those compliance certifications as well. And we also enable encryption in transit and at rest for the data which is on Azure. In terms of cost effectability, this is something I wanted to share with you, that typically you have tiers of storage, and this is where lifecycle management comes very handy, that if you have stored a premium storage, your cost would be like somewhere in this range. And plus, if you are storing the data in a frequently accessed storage tier, the average comes out to be 18 terabytes a month. And then if you have lifecycle policies to move to the data to the cooler storage after maybe 2 months or 3 months, you see how the price goes down and the archive really comes down to $1 a terabyte. So definitely we have options available, and the technologies which enable the fast retrieval times is the premium is all SSDs, and hot is the high density disk drives, and same with cool and archive. So cost control is there, and the biggest thing is that the data lake, because it enables you, enables you to run multiple analytic frameworks. It is the foundation for high-scale analytic platforms in most of the businesses. And on Azure, we have Azure Synapse Analytics, Databricks, Azure HD Insights, which definitely use Azure Data Lake capabilities to run their analytics underneath it. And here is some example I wanted to give about what is a big differentiator on the Azure Data Lake storage that we added 2 years back is the ability to have true directory structure, not just that directory structure where we have it on we used to have it on a blob storage, where it was a virtual directory structure. It looked like you are organizing data, but it was not. It is not really a true directory structure. True directory structure is something like if we have worked on Linux platform and you create the folders, subfolders, and other folders, and you're able to control permissions and access at the granularity of folder level. That is the true hierarchy and true directory structure. And that is something which Azure was the first to add on their, on their storage. They kind of combined the blob and the file storage into one, where you could support this directory structure. And this is very paramount when you're doing analytic platforms, because there mostly you work with files sitting in the folders. And when you want to do pruning and looking at the data in a performant manner, that's when you need the directory structure. It is not possible to get that kind of performance in a virtualized directory structure like a blob storage or a S3 storage or other native storages which do not support this kind of structure. So that is a differentiator. And in the past, we used to always have this discussion with customers when they started to have to move data to Azure. Okay, what are you going to do with the data? Are you going to be using it for doing backups, or are you going to be doing certain kind of operations? So people would dump it into Blob, but then we had an Azure Data Lake Storage Gen 1, which would enable you to create these folder structures and enable to give you those granular file accesses, which were pretty fundamental to run those high analytic frameworks. So in terms of the kind of changes we did, this makes it very performant storage to do your analytic work. And here, and what we did with our Azure Data Lake storage is bring in those features of blob storage, which were not available in Azure Data Lake Gen 1 storage, and bring them, merge them together. So the things which I wanted to call out, which were there in blob storage, was ability to replicate or have your data available in the LRS or ZRS replication mode based on how you wanted your data to be available. Those things were not that easily available on the Azure Data Lake storage. You could only be able to replicate your data within your data center, but not outside, and that was a limitation. So we didn't have the security which was at this level. Was not available in Azure Data Lake Gen 1. So all the blob components, the lifecycle management capabilities and things which were available in blob storage, we came up with this, this architecture, which has been active and working for last 2 years, is basically enable this storage, which is built on the blob storage foundation. And Blob offered you the ability to do object tiering and lifecycle management, all the RBAC security, Active Directory integration, and ability to store, to provide replication. And on top of that, we had these 2 silos earlier, but now they are no longer silos, still built on that foundation. Only differentiation is you have different APIs to access that data, and you get full advantage of using you get a performant data lake storage Gen 2 architecture. So I just wanted to bring this up because this is also the foundation for the next topic I'm going to move into, the Azure Synapse Analytics. So this hierarchical file system, which is what is the capability we added with merging the 2 storages, was to be able to build security at the storage level. It's more performant. Like I talked about, if you have to do a simple delete and rename operation on a blob storage, it will be it's a metadata operation when it comes to doing it in a system which has hierarchical file system enabled versus doing it on a blob storage, which doesn't have that. So cost and yes.
From a timing standpoint, as we're moving ahead, and so interesting to learn about data storage platforms, but if you could cover the Synapse in about 10 minutes so we keep things moving along, that would be great. I know it's short, but we can just request follow-up questions afterwards.
After that. Okay, sure. Let me do that. So this is my slide. Just I'll quickly go through that on Data Lake, we do support all these systems. But now comes Synapse Analytics. This is our newest, I would say, fully GA'd platform from December 2020. This is our old SQL data warehouse, which was kind of moved into with a lot of enhanced capabilities. And first time with the new capabilities and with the new name, it was launched in Ignite 2019. And with the foundation that most of the businesses have are still trying to understand data, their data silos. And when we are talking about it in the last 10 years, there were two distinct silos created in organizations, which were the data scientists like to work on data lake because their area was mostly related to big data experimentation and dealing with granular data, semi-structured data, but data warehouses were another area where analytics were housed with pretty much dealing with structured data and dependable performance. But it was a challenge to combine the two because security was a big thing. Because how would you secure a relational database? And you can only secure a relational database, but when the data is sitting on data lake, how do you do the security management on that? And on that, I'll be rushing through a couple of slides here just to cover the main concepts. But typically on data lake, data is coming from everywhere. It's an experimentation platform. You cannot secure all what you do not know, but still, if you have the granularity, if you know how to do that, you would like it to be more simplified. User management at one place, and these jobs are, if we have data warehouse, we know exactly what kind of workloads are coming. But on data lake, we do not know. So mission critical would go on one side and a non-mission critical would go on data lake. So it was a challenge to keep them together. And with that feedback from the market that there were two different silos of analytics in any business, it was hard to tie them together, came up with this version of Azure Synapse Analytics, which really brings in both the data scientist and the, the data analyst together, because now you can handle both structured and unstructured data just right at one location. So this is where Azure, what we call Azure Synapse Analytics, but let me go to the main slide, which kind of talks about this platform and try to go into the details here. So Azure Synapse Analytics, like I talked about, is a platform. On the left side, you have data coming from any sources. It could be any cloud, it could be any SaaS services streaming on-prem, but the foundation is really the Azure Data Lake storage. And the data stored there is then on top of, if you go a level up, we have analytic runtimes. And this is unique about Synapse platform, where you have three engines, which I'm going to talk about. One is the SQL engine, which is the provision SQL engine, which supports the traditional SQL data warehouse, which we also call as the dedicated pool. That's where you get the data coming in from other relational platforms and you want a quicker SLA, you put the data there. But then we also have SQL serverless, which is another form where the data sitting on data lake, you can do SQL on top of that data lake. And that is the form of that is the SQL serverless form. So we have a SQL dedicated, a provision pool, and the serverless pool here, the second engine. And you won't believe most of the organizations I've been lately working with have been using serverless to a great advantage, because now the data scientists can do all their exploration using the SQL serverless and only land the data which is of high business value into the dedicated pool. Then the other engine, which is part of Synapse, is the Spark pool. It's the open source Apache Spark. We support that within this Synapse. You can bring in your own libraries, build your Spark code, machine learning, and what do you call AI machine learning models right within here. And then the management, integration, monitoring, and security is all built in within the Synapse platform. And the one which builds the integration experience is the Azure Synapse Studio. And on the outside is like you have built-in connectivity with Azure Machine Learning Services. So the models you build within Azure Machine Learning, they can get converted to ONNX format, and you can score them real time using Power BI. So this is our Synapse platform. And other thing which we have coming up, or which we came up couple months GA'd last year, was the Synapse Link. Synapse Link, like there was always a gap between the analytic systems and the operational systems, and an operational system was not allowed to, users were not allowed to query it during the day, and they had to move the data to a data warehouse to be able to query it. But with Synapse Link, your data from operational systems lands is available to analytic systems without any ETL. All you need to do is just enable it. And that's the value of Azure Synapse Link. And I want to quickly, within a couple of minutes, if I have time, I just wanted to show you this, this interface here of Synapse Studio, where once this is your landing page, then you have your data page, where data hub, where you see your data sitting in the data lake, Cosmos DB, whatever you're connected to. And then once you are here and you're trying to explore your data lake, you don't have to go to a storage explorer or what do you call an Azure portal to go and look at what is in the data and look at these Parquet files. There is no easy way to look at it, but if you want to run SQL on top of it, all you do is right-click and you'll get a code here. And this brings in your serverless component I was talking to. And if you run it, it's just going to quickly return you the results of that query. So you see this is, I have to move this. So here, this was a Parquet file, and you see how the data looks. It looks good. It does not. You could do group by, order by, all kind of operations, partition pruning, build your data sets, write them to the data lake, and then have those data sets read in Power BI or any of your BI tools. So that offers that capability. Similarly, if you want to load that data or create an external table or create a bulk load of a group of files here, these Parquet files, all you do is click on bulk load, and the schema, because it supports schema read, you can read the schema, build the code, and create the name of the table test, and then the code is automatically ready for you to get it landed into your dedicated pool. Other than that, like there is what do you call? You can write your SQL scripts here. You can build your, one thing I wanted to show is for somebody working on Spark and wants to load the data to data frame, you could just right-click and there comes your Jupyter notebook, and you can just get started on writing code right here. All you need to do is have connect it to your Spark pool and just run the code right there and start building your models right here. So you have the ability when you're developing, either you're developing SQL or you're developing notebooks or you're building any ingestion pipelines, you could just start it right from here. You don't have to go to Data Factory and try to build your pipelines and do that. So this is this is an integration studio where you can build your ETL, you can do your development, you can run your code, and you could monitor your code once it's submitted. Like here, there are multiple ways where you could create triggers, and if you want to run a code or a pipeline, all you do is you just have to add a trigger and trigger it now. Oh, sorry, I just wanted to show you that once you have created a trigger and you want the files to be automatically loaded, you could just say, okay, I want to create a new trigger, and then you want it on a schedule, then every 7 p.m. you want to run it, you could do that. You can do a tumbling window where you can build your file loads or your ETL run every 15 minutes, or you could have a storage event that based on the file line lands in a file, in a folder, you could have those events started, or you can have custom events. So this is like a full-fledged ETL orchestration and monitoring as well. And it's not just dedicated pools only. You could go and monitor any of your Spark jobs. You could build this is the canvas where you could go and build your full data pipelines. Monitoring of your pipelines happens right here. I submit a job, I could do that. Anything with trigger runs will show up. Any of your Spark applications, they are right now, the pools are stopped. You could go and monitor them right from here. Any of your SQL pools, like the dedicated pool, like this is my SQL pool. If I want to scale it up, I could go and just click on it and get the slider button and go and scale it up right here.